Hi friends, in this video our topic is saturated synchronous impedance method. Why we are preferring saturated synchronous impedance method? Because we already read about EMF method and MMF method. These two are not accurate methods. Why not accurate methods? One, here measured voltage regulation is more than actual. Here measured voltage regulation is less than actual. Why here more? Because measured synchronous impedance is more than actual. Here measured synchronous impedance is less than actual. Why like this? Here saturation is not considered. Saturation, what happens are here? Not considered. But here more saturation considered. These are the problem. That's why this method is called optimistic method and this method is called pessimistic method. And also here total drop due to XA, here total drop due to XL. Here drop due to XL is considered as additional XA drop. Here drop due to XA considered as additional XL drop. Here we are calculating ZS, that is equals to EOC upon ISC, then calculate RA, then calculate XS, then calculate EMF, then calculate voltage regulation E minus V upon V. This is simply EMF method. But here calculate IFR, which is sum of two field currents for lagging, leading and unity power factor. Then find corresponding ER. Then find voltage regulation ER minus V upon V. This is finally the difference between EMF and MMF method. Actually, you have to do this chart. Then you can get a complete idea. Yes or no? Right? This is your work. From now onwards, every topic you should make like a chart. You never forgot this. Okay? So let's go for saturated synchronous impedance method. Here in this method also total drop is equals to drop due to XL, same, and drop due to XA is considered as drop due to additional leakage reactance, same. And here also we required OCC and SCC characteristics. OCC characteristics are like this. SCC characteristics are like this. Same. But here, for example, this is our rated voltage. Here the current is called IFOC. This rated voltage is taken as EOC and corresponding current on short circuit is taken as ISC. This is the difference between unsaturated synchronous impedance method and saturated synchronous impedance method. What is the difference? There we calculated at IFSC. We calculated at IFSC, right? But here we are going to calculate at IFOC. Are you getting or not? Actually, how the synchronous impedance? The synchronous impedance is actually like this. Here more, here less, but here mostly equals to actual. Mostly equals to actual. This is we are modified. This saturated synchronous impedance method is modified method of synchronous impedance method. This is that modification. Then what, sir? Then what? Everything is same. Then find the ZS. ZS is equals to EOC upon ISC with respect to IFOC. We calculated this as also in EMF method, but with respect to IFSC, but here IFOC. And find RA. I said you how you can find RA, and then find XS. XS is nothing but Z square minus R square. We know this, yes or no? So I calculated. Then find the EMF. How we can find the EMF? We know V cos pi plus IA RA whole square plus V sin phi plus or minus IA XS whole square. Everything is same. Here the voltage regulation is equals to E minus V upon V. Everything is same. No change, only one modification from IFSC to IFOC. Then we can get the actual voltage regulation. In this method, the measured synchronous impedance is nearly equals to actual synchronous impedance. In this method, measured voltage regulation is nearly equals to actual voltage regulation. This is good method, of course, but can you tell me what is drop due to XL? Can you tell me what is drop due to XA separately? I am sorry. If you want the total drop, I will give you. But don't ask me like that. What is the separate drop? Okay, don't ask me like that. That is the disadvantage of this method. Okay, so the measured voltage regulation is good. Measured impedance is good. We are getting the nearly equal answers, but we don't know what is separate drop. What is the percentage of separate XL and XA, even though armature resistance neglected. So this is what the saturated synchronous impedance method. So on board we have three methods: EMF method, MMF method. This EMF method is also called synchronous impedance method, and this is ampere turns method, and this is saturated synchronous impedance method. This is the first part in indirect voltage regulation methods. What is the next part? ZPF method and ASC method, both are combined. These three are combined and those two are combined. ZPF or Portier triangle method and American Standards Association method. Okay, this is understood, right? Thank you.